Alright folks, in this video we're looking at a new topic we'll just cleverly call curve sketching. So um, the idea here is we've looked a lot, we've learned a lot of techniques for finding derivatives, and we apply that a second time to get the second derivative for a function. And more recently we've been looking at what the first derivative and second derivative tell us about the function. So what we're doing here is we're going to gather up all that information along with information we know about the function just by looking at the functions, some pre-calculus ideas, things like, well, we'll look at it in a second. Put all that together to see if we can sketch a graph of the function. Now, one thing you want to keep in mind, it's always a good idea to think about, why am I doing this? Why is this useful? We're not doing this so that we get good graphs of functions. Anything we do by hand, as good as it might be, it's going to be a million times better using technology. So the reason we're doing this is not to get really good at graphing. It's because this process helps us kind of tie together all these things that we've been talking about and reinforces these ideas that we've been looking at. That's what I've got here with the note. So don't think that we're training ourselves to be really good at graphing. We're really just kind of reinforcing these ideas. And if we get a little bit better, we might find that helpful as well. But that's not the end game here. So looking at the function, we can determine a number of things. We can figure out the domain, might know the intercepts, both x and y. We could look at maybe some symmetries and maybe some asymptotic behavior, vertical asymptotes, horizontal asymptotes. Maybe if you've looked at it, slant asymptotes, sometimes called. As far as the derivatives go, from the first derivative, we can get information about where it's increasing and decreasing, and from that, make conclusions about local maxima and minima. For the second derivative, we can determine the concavity behavior, where it's concave upward, where it's concave downward, and from that, inflection points as well. So there's not really much else to say, so all I have left for you in this video is just to look at an example. So, got our function here. So let's look at function f of x is e to the negative x times sine of x. We'll have a restricted domain. We're just going to worry about between negative pi and pi. And let's see what information we can get from just the function itself. First of all, we could look at the domain. No problems here, no restrictions. E to the negative x is never 0, never, so we don't have any problems, is what I'm trying to say, kind of clumsily. So all real numbers, no division by 0, no square roots and negatives, nothing like that, no problems. This doesn't have any symmetry to it, at least the types that we usually would consider. It's not symmetric about an axis, and it's not symmetric about the origin. Intercepts. For the y-intercept, we would just need to evaluate. F of 0 is e to the 0 times sine of 0, which is 1 times 0, which is 0. So that's our y-intercept. Our x-intercept, remember we want to solve, where does f of x equal 0? We want to figure out where f of x equals 0, so we want to solve this equation, which would be e to the negative x times sine of x is 0. Now, e to the x or e to the negative x is always positive, never negative and never 0, so this is going to have the same roots, the same zeros as just sine of x. And that's going to happen where x equals negative pi, 0, or pi. Remember, with this restriction that we've got up here. Okay, so those are my x-intercepts, at least the x-coordinates of my x-intercepts. Anything else that we might want? Maybe our asymptotes. We don't have any vertical asymptotes. For horizontal, we might look, let's see, limit as x goes to infinity of sine of x over e to the x is 0. And we could figure that out, using something like a squeeze theorem type setup, because the sign is going to bounce between -1 and 1, but the e to the x is going to blow up. So we get larger and larger and larger values, so the whole thing is getting closer and closer to 0. The limit as x goes to negative infinity well, that does not exist. Because the e to the negative x, that's going to blow up. You're going to get e to a larger and larger and larger power, so that whole thing, the magnitude is just going to get bigger and bigger and bigger, but the sign is going to go between, back and forth, positive and negative, and it'll be 0 at every integer multiple of pi. So it's going to have some crazy oscillating behavior moving to the left on the number line, but that limit does not exist. So horizontal asymptote of y equals 0 to the right. Alright, so we got that. Let's look at some derivative information. So first of all, let's figure out the derivative. Derivative is going to be, using the product rule, negative e to the negative x times sine x plus e to the negative x times cosine of x. And so that's going to be e to the negative x, negative sine x, plus cosine x. So let's figure out some critical numbers. We want to know, this is defined everywhere, we don't have any problems, so we want to solve this equation. Where does f prime of x equals 0? So where does e to the negative x times negative sine x plus cosine x equals 0, which happens exactly where negative sine x equals, negative sine x plus cosine equals 0, which is cosine x equals sine x. So on this interval, negative pi to pi, cosine x equals sine x. Where does that happen? Well, it's going to happen at pi over 4. And the next one I might think of is 5 pi over 4, but that's not in the interval, so I'm going to kind of go backwards. We'll say negative 3 pi over 4. That would be where cosine equals sine within that interval. So I'm going to play my game where I'm thinking about in between those critical numbers, what's happening? Something less than negative pi over 4. Well, let's see, what would we have? Let's do something in between. How about at 0? It's going to be positive. Something out here, let's try something out here. Let's try pi over 2. Pi over 2, it's going to be negative. And out here, try something, if you want a specific value, but the derivative is going to be negative. So the function is decreasing, decreasing, then increasing, then decreasing. So decreasing from, let's say, negative pi to negative 3 pi over 4 and pi over 4 to pi, and increasing from negative 3 pi over 4 to pi over 4. And we're going to have a min right there, and we'll have a max right there. Second derivative information. Remember, the first derivative was e to the negative x times negative sine x plus cosine x. So the second derivative is going to be negative e to the negative x times negative sine x plus cosine x plus e to the negative x times negative cosine x minus sine x. And so the second derivative is e to the negative x. Now let's look at what's happening when we're grouping some things together here. So that minus makes that sign just positive sine x minus sine x, so that's gone. And I've got a negative cosine x, another negative cosine x, so negative 2 e to the negative x times cosine x. So I want to figure out, this is defined everywhere, so I want to solve where does this equal 0? And so we want to figure out where does this equal 0, where does negative 2 times e to the negative x cosine x equal 0, and that's happening exactly where cosine x is 0. And that occurs for x equals negative pi over 2 and pi over 2 on the interval in question, negative pi to pi. Alright, so we play our game again, try to figure out these intervals where things are happening. You got negative pi over 2, pi over 2. And between negative pi over 2 and pi over 2, something like 0, this is going to be negative. Something bigger than that, we have a negative value there. Negative makes that whole thing positive. Something less than negative pi over 2, negative, negative, positive. So out here the function's concave up, concave down, concave up. And we have inflection points at negative pi over 2 and pi over 2. Alright, so I've got a 0 at negative pi, 0 and pi, negative pi, 0 and pi. I'm increasing I start off decreasing, and I'm increasing from negative 3 pi over 4 to pi over 4, and then I'm decreasing again. So running short on time here, but it looks like I've got something maybe kind of like that. So the video is about to cut out. We did all the hard work. Here's what the real graph looks like. Not too far off.